above the principal axis are taken as positive and the distances below the principal axis are taken as negative. So here, and the incident ray, the direction of incident ray is taken as positive and the direction opposite to that incident ray is taken as negative. So these are the sign conventions. So according to sign convention, so here P O dash P be the incident ray. The incident ray strikes on the lens, convex lens. So then what will happen means it gets refraction and the image is formed same side of the object and the image is formed same side of the object. So here P O double dash be the image of the first curved surface. So here and this image of the first curved surface acts as a virtual object of the second curved surface. Virtual object of the second curved surface and it forms an image at eye. It forms an image at eye. So here O dash P is the incident ray of first curved surface and P O double dash is the image of the first curved surface and P O double dash acts as a virtual object of the second curved surface and P I be the image of the second curved surface. So here O dash to O, optic center to object. The distance between optic center to object is known as object distance U and optic center to image. The distance is known as image distance V1. So V1 is the image distance of first curved surface and after this will act as a virtual object of the second curved surface. So that's why and OI be the image of the second curved surface. Image of the second curved surface and mu1 mu2 be the refractive indices. Okay, refraction at first curved surface according to sign conventions. According to sign convention, mu is the length of the lens, so that's why it will be negative. So here according to first curved surface, so here what is the object distance? Object distance is u and the image distance is v1 and the radius of curvatures are r1 and r2. Radius of curvatures are r1 and r2. So here radius of curvature r1. So these equations are substitute in the above equation. Then what we have to get means here minus mu1 by u plus mu2 by v in place of v1 that equals to mu2 minus mu1 by r1. This is the refraction at first curved surface. So what about the refraction at second curved surface? Refraction at the second curved surface. Refraction at second curved surface is here mu1 be the refractive index. Refractive index. So here it is rarer medium, it is denser medium. So it is a rarer medium and it is denser medium. So mu1 be the refractive index of rarer medium and mu2 be the refractive index of denser medium. So according to second curved surface, in place of mu1 we have to substitute mu2. In place of mu2 we have to substitute mu1. So from that, according to second curved surface, what is the object distance? v1 be the object distance and image distance is v. Image 1 by R1 minus 1 by R2. So here from this equation mu1 we have to take a mu1 to the right side. Then what we have to get here 1 by V so 1 by V minus 1 by U is equals to mu2 minus mu1 by mu1 into 1 by R1 minus 1 by R2. So this is known as Lenzmaker's formula. This is also known as Lenzmaker's formula. So what is Lenzmaker's formula means? Minus mu1 by u plus u1 by v is equals to mu2 minus mu1 into 1 by r1 minus 1 by r2. So this is known as Lenzmaker's formula. So by using Lenzmaker's formula, we have to derive Lenz formula also. So here, so this is nothing but Lenzmaker's formula. So what is Lenzmaker's formula? Minus mu1 by u plus mu1 by v, that equals to mu2 minus mu1 into 1 by r1 minus 1 by r2. So this equation is known as Lenzmaker's formula. So from this equation we have to derive Lenz formula also. How can we derive Lenz formula means? From that equation 1 by v minus 1 by u is equals to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. So suppose for example if the object is at infinite distance, if the object is at infinite distance, so if the object is at infinite distance, if the object is at infinite distance, so then what will happen means u is infinity. Infinity means the light rays are parallel. The light rays are parallel. Then the image is formed at focus. Image is formed at focus. So that's why here v is equals to f. So here from that we have to substitute these u is equals to infinite and v is equals to f in that above equation. Then 1 by f minus 1 by infinity is equals to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. So here this equation can be written as 1 by f is equals to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. So here from these two equations we have to observe that this is equation 1 and this is equation 2. From these two equations what we have to observe? So right hand sides are equal. So that's why left hand sides must be equal. So from that 1 by v minus 1 by u is equals to 1 by f. So this is nothing but Lenz formula. Lenz formula. So this is Lenz formula. So if the object is at an infinite distance, then the light rays are parallel. If the light rays are parallel, then what will happen? The image must be at focus. So that's why v equal to f. So we have to substitute these two in above equation. Then we will get Lenz formula. So power of lens. Power of lens is nothing but the ability of diverging or converging lens is known as power of lens. And the definition of power of lens is meter inverse. It is represented by the letter capital D. Okay. So here, what is combined focal length? What is combined focal length? So let us consider two lenses L1 and L2. Here optic centers are O, O dash and F1 and F2 be the focal length of the two convex lenses. So here this is the incident light ray. Whenever the incident light ray incident on the first convex lens of focal length F1, and then what will happen? It gets a refraction and the image is formed at I dash. So here this is acts as a object of the second convex lens. After that then the image is formed at I. So here this is the incident light. Whenever the incident light ray is incident on the first convex lens of focal length F1, the image is formed at I dash. The image is formed at I dash, and the image of the first convex lens acts as a object of the second convex lens of focal length F2. Then the image is formed at I. So here the image distance, so the object distance is U. This is the object distance of the first convex lens, and V1 be the image distance of first convex lens, and V1 be the object distance of second convex lens, and V be the image distance of the second convex lens. So here already we know that what is lens formula? 1 by F is equals to 1 by V minus 1 by U is the lens formula. So 1 by F is equals to 1 by V minus 1 by U is the lens formula. So according to first convex lens, focal length is F1 and the image distance is V1. Object distance is U. So this is the focal length of the first convex lens, and what is the focal length of the second convex lens? 1 by F2 is equals to, here V is the image distance of the second convex lens, and so here V is the image distance of the second convex lens, and V1 be the object distance of the second convex lens. So this is equation 2. So what is the combined focal length? Combined focal length means we have to add these two, then we will get combined focal length. So that is 1 by F1 plus 1 by F2 is equals to 1 by V1 minus 1 by U plus 1 by V minus 1 by V1. So here plus 1 by V1 minus 1 by V1 get cancelled. So from that 1 by F1 plus 1 by F2 is equals to 1 by V minus 1 by U. This is also nothing but 1 by F. So from that 1 by F1 plus 1 by F2 is equals to 1 by F. So 1 by F1 is nothing but power P1 plus P2 is equals to V. So here P1 plus P2 is equals to P. Means the sum of the individual powers is equals to their total power we will get. So suppose for example these two lenses are separated by a distance D. So then what is the combined focal length means? If two lenses are separated by a distance, two lenses are separated by a distance D, then the combined focal length is, so 1 by F is equals to 1 by F1 plus 1 by F2 minus D by F1 F2. So from this P is equals to P1 plus P2. So 1 by F1 minus D 2. This is the combined focal length. This is the combined focal length when two lenses are separated by a distance d. Then the power is p is equal to p1 plus p2 minus d into p1 p2. Gives the power. Next concept is refraction by prism. So let us consider a prism A, B, C. So here PQ be the incident ray. The incident ray strikes on the first surface of the prism. Then what will happen? It gets refraction. So it gets refraction. So that refracted ray is QR. So after that what will happen? Again this refracted ray strikes on the second surface of the prism and that light ray gets emerged. So here let us draw a normal on the first surface of the prism. So this is the normal. So here the angle between normal to incident ray is known as angle of incidence I. So here the angle between normal to refracted ray is known as angle of refraction R1. So again we have to draw a normal on the second surface of the prism. Then what will happen means here. So this is the normal drawn on the second surface. So these two normals are coincidence at point L. So this is the emergent ray. This is the emergent ray. So that emergent ray is known as RS. RS be the emergent ray. So this is the normal and this is the emergent ray. The angle between normal to emergent ray is known as angle of emergent E. Here this is the PQ be the incident ray. So this incident light ray travel from rarer medium to denser medium. Here the refractive index of rarer medium is N1 and the refractive index of denser medium is N2. So here whenever the light ray travel from rarer medium to denser medium, then what will happen after refraction? The refracted ray moves towards the normal. This is the normal. So that this is the refracted ray. The refracted ray moves towards the normal. So after that this refracted ray, so this is denser medium. So whenever the light ray travel from denser medium to rarer medium, after refraction the light ray moves away from the normal. So this is the normal and this is the emergent ray. So here this is the incident ray. So this is the refracted ray of first surface. This is and incident ray of second surface. So here the light ray again refracted emergent. So after that what will happen means the refracted ray moves away from the normal. Why? Because here that light ray travel from denser medium to rarer medium. So that's why the refracted ray moves away from the normal. So here see once we have to extend the incident emergent ray. So whenever the PQ is incident on the first surface of the prism, so the light ray is in rarer medium. Whenever it travels from rarer medium to denser medium, after refraction the refracted ray moves towards the normal. So after that again this light ray QR, this light ray it strikes on the second surface of the prism. So this is the denser medium and it is the rarer medium. So whenever the light ray travels from denser medium to rarer medium, the refracted ray or the emergent ray moves away from the normal. So here, so this is the refracted ray. So refracted ray, this is the normal. So that's why here the angle is R2. Okay. So from the here AQLR, from the quadrilateral AQLR, angle A plus angle QLR is equals to 180 degrees. Angle A plus angle QLR is equals to 180 degrees. So this is equation 1. So from the triangle QLR, so here this is the triangle QLR. So here the angle is R1, here the angle is R2. So the total is 180 degrees. So from that R1 plus R2 plus angle QLR equals to 180 degrees. So this is equation 2. So from equation 1 and 2, right sides are equal, so left sides must be equal. So angle A plus angle QLR equals to R1 plus R2 plus angle QLR. So here angle QLR get cancelled. So from that angle A is equals to R1 plus R2. This is equation 3. Okay. So here let us draw a graph between angle of incidence to angle of deviation. Angle of incidence to angle of deviation. So we have to take angle of incidence is along x-axis and angle of deviation is taken along y-axis. From this what we have to observe means the graph is in U shape. So if the angle of incidence is increases, then the deviation is also increases. The deviation is also increases at certain angle of incidence. The deviation angle is minimum. So at which angle of incidence? The deviation angle is minimum means that is delta m. Why? Because minimum deviation angle. So how it will get means whenever the incident angle is equals to emergent angle, then only we will get deviation, minimum deviation. So whenever the I is equals to E means emergent angle which is equal to incident angle, then only we will get minimum deviation angle. So here from this I is equals to E, whenever I is equals to E, then we will get minimum deviation angle. Okay. So from that here see once from the triangle, this is Q, this is R. Suppose for example this is T. So from the triangle Q is the external angle, these two are internal angles. So here external angle equals to sum of the internal angles. So delta is equals to I minus R1 plus E minus R2. E minus R2. So here delta is equals to I plus E. Let us take a common minus R1 plus R2. So here delta is equals to, from equation 3, what is R1 plus R2? A. So I plus E minus A. So here for minimum deviation angle, then I is equals to E. So from that delta is equals to, in place of E, I have to substitute I minus A. So this is nothing but the minimum deviation angle. Why? Because we have to substitute in place of E, I. So that's why that angle is known as, angle of deviation is known as minimum deviation angle. So from that delta M is equals to 2I minus A. From that 2I is equals to delta M plus A. I is equals to delta M plus A by 2. So this is equation 4. For example, that is equation 4. Okay. So here from the at angle Q. So at point Q, not angle. At point Q, what is Snell's law? So at point Q, Snell's law is, at point Q, the Snell's law is, so what is Snell's law? N1 sin I is equals to N2 sin R. So here sin R is nothing but R1 at point Q. So at point Q, angle of incidence is I and angle of refraction is R1 and the refractive indices are N1 and N2. So that's why at point Q, N1 sin I is equals to N2 sin R1. Okay, at point R. So at point R, what is Snell's law? At point R, Snell's law is, so here N1 sin, in place of I, it is E. N1 sin E, here the angle, here the refractive index is N1. So that's why N1 sin E is equals to N2 sin R2. So this is equation 5 and this is equation 6. Here also for minimum deviation angle, I is equals to E. For minimum deviation angle, I is equals to E. So at point P, Snell's law is N1 sin I. Here the angle of incidence is I. So N1 sin I is equals to N2 sin R1. At point R, what is Snell's law? N1 sin E is equals to N2 sin R2. So for minimum deviation angle, what is the condition here? I is equals to E. I is equals to E. So then delta is equals to delta M, minimum deviation angle. So from that N1 sin E, in place of E, what I have to substitute? I is equals to N2 sin R2. So this is equation 7. From equation 5 and 7, R1 is equals to A by 2. So this is equation 8. So according to Snell's law at point P, sorry, point Q, according to Snell's law at point Q. So N1 sin I is equals to N1 sin I is equals to N2 sin R1. So already we know that from equation 4 what is I? A plus delta M by 2, and what is R1? A by 2. So from that N2 by N1 is equals to sin I by sin R. So here we have to substitute the values of I and R1. Then sin, what is A? What is A? Here I. What is I? A plus delta M by 2 by. What is R1 here? Sin A by 2. So here N2 by N1 is equals to sin A plus delta M by 2 by sin A by 2. So here the refractive index of A is 1. So from that, if N1 is equals to 1 and N2 is equals to N, so then N are new. So that's why N by 1 is equals to sin A plus delta M by 2 by sin A by 2. So here N are new. So that's why the refractive index of the prism, it is represented by mu r, n is equals to sin A plus sin mu r n is equals to sin A plus delta M by 2 by sin A by